I'm going to leave the presentation of yourself and your session to you. I just know it's about Delta Lakes and things I normally don't work with, and Databricks. So I'm very excited for it because I think I will learn something. The only thing I want to know from you, Mohit, is do you want questions during the session, or will you stop for Q&A during the session or after it?
Yeah, first of all, thank you, Magnus, for having me here. And I would really, I'm really thankful for people who have joined in. And I would love to have, questions during the session itself. So, that will make it more interactive instead of, people going through and getting bored by a lot of stuff, and waiting for their questions to be answered at the end. So I would love to have the questions in between. I normally also keep an eye on the chat panel. So, but I would love, if you would want to interrupt me anytime and, share the questions. I'll be happy to answer them.
So for everyone, don't use the Q&A panel, use the normal chat window to post your questions. That's my advice, because then I will see it and probably Mohit will see it before as well. So, Mohit, welcome. The stage is yours.
Yeah, thank you. I'll just go ahead and share my screen. And let me just set it up, all the chat windows and the participant windows, and I think I'm good. Hope you can see my screen.
I see the screen, yes.
Okay, I think, I see good number of participants are in, so I think we can get started as well. So once again, thank you, Magnus, and your team for having me here at the GroupBy. I'm really excited to, in fact, I'm very excited to, present here, and I look forward to deliver a session which will be helpful for everyone who have joined in. So guys, thank you so much for joining in. And this session is all about Delta Lake, and we'll be using Azure Databricks. First of all, of course, we'll be talking about what is Delta Lake. We'll also look into how we can set up the Azure Databricks environment. And then we'll see that what are the different features available in Delta Lake and why do we actually need that. Okay, so let's get started, and let me first share some brief information about myself. You already know my name is Mohit Batra. I'm founder at Crystal Talks, a company which is into training and consultancy. I'm also an author with Pluralsight, so I do publish a lot of video content there. And I, of course, not just Pluralsight, but I do publish content at the other places as well. And I have published courses on Databricks, Synapse, Snowflake. So that is my area of work. I work as a data engineer and, of course, work with a lot of data as well. I'm also a Microsoft certified trainer. And of course, I do a lot of classes as well. And prior to working full time as a trainer and a consultant, I worked with companies like Microsoft. And I'm sure some of you must be knowing Saxo Bank. It's a Denmark-based investment bank. And there also I worked as a data engineer. My LinkedIn profile is there on your screen. So if you wish to get in touch, I'll be more than happy to connect with you. Okay, so that's a quick introduction about me, and let's get started and look into what is the agenda for today's session. I hope, Magnus, I've got around 1.5 hours to complete the session.
Yeah, next session starts, well, 1.5 hours from 6. So let's say 80 minutes. That would be good.
Okay. Sure, thank you. Okay, so let's let's talk about what are the things we are going to look into. First of all, we'll talk about what are the challenges associated with Data Lake. Now, Data Lake, these days, everybody is talking about Data Lake. People are using them in their projects, and a lot of people I meet, they are planning to use Data Lake and for their organizations to build up their warehouse, keep all their raw data, their process data, everything in one single place. But of course, as we start using a technology in a lot of depth, obviously there are a lot of challenges associated with that. So what we'll do, we'll go ahead and talk about the challenges associated with Data Lake. Followed by this, we'll talk about what is a Delta architecture. So of course, we haven't touched upon what exactly is Delta Lake, but first we'll talk about what is Delta architecture and where does Delta Lake fit in. And then we'll see that what are the different, what exactly is Delta Lake and how it works. And of course, followed by this, we'll look into the demo, and that's where we'll be spending most amount of time. We'll look at the features of Delta Lake, how exactly it is working, and how it can benefit you in your projects. So that is the agenda. So let's get started by looking at the first thing, which is the Lambda architecture. So I talked about, I mentioned that we'll look into into the challenges of data lake. But before that, let's understand what is Lambda architecture. I'm sure many of you must have seen the Lambda architecture. Let's quickly talk about that. Now, in case of Lambda architecture, let's assume that there is a lot of streaming data that is coming in. It could be data coming from IoT devices. It could be data coming from, let's say, the log files. So there is a lot of data that is continuously getting generated. And now we want to get that data processed. When we talk about the Lambda architecture, so what we can do, whatever streaming data is coming in, we can store that data into some kind of stream ingestion service. Let's say it could be Kafka, or it could be Azure Event Hubs, or it could be AWS Kinesis. We can just go ahead and store that data into some kind of stream ingestion service. Now, once we have this data into, let's say, Azure Event Hubs or any stream ingestion service, then we can go ahead and process that data using Apache Spark. Now, if for this particular session, it's required that you have a basic understanding of Spark. So Spark is basically an open source engine which can help us do distributed data processing. So what we can do, we can pick up the data from Azure Event Hubs and process it using Azure Databricks. And Azure Databricks is basically a platform which is based on Apache Spark. So we can take the data from Event Hubs, which is continuously coming in, and perform stream processing of data. So continuously we are processing the data here. And once we process this data, we can go ahead and store the processed data into data lake. When I say data lake, it's more about we are having a storage and we are keeping that data. We are storing the data as in the form of files inside data lake. So whatever data is coming in, we are continuously processing it and putting it into data lake. And of course, once we have the data in the data lake, we can go ahead and use Power BI or any kind of reporting tool to visualize that data. And of course, once we have that processed data, we can use that in the downstream application. So there are various use cases in which we can use this processed data. On the other side, now this is all about streaming data, but of course, streaming data, it does not give us the, it may not be able to apply too much transformations, because obviously we are, we have to process the data very, very quickly. So it may not be possible for us to apply too much transformations or machine learning on this incoming data. For this purpose, what we can do, we can go ahead and, of course, we can again store this data which is coming in to Event Hubs into some kind of data lake. Now, on one side, we have got the processed data which was coming inside, which we have processed. On the other side, we are also storing the raw data into the data lake. So we now have the raw data and we have the processed data from streaming inside data lake. Now, what we can do, once we have this raw data available, maybe at the end of every day or every 6 hours, we can go ahead and start doing batch processing of data. Again, we can use Spark to perform the batch processing. So we'll take this raw data, which is there in the Event Hubs. We'll take this raw data as well as, any kind of historical data. We can combine them and start doing the batch processing of data. And this is where we can apply a lot of machine learning. We can apply a lot of transformations, and we can store this data again back to data lake. Okay, now this is what we have in the Lambda architecture. And we are able to process the streaming data as well as we are able to process the batch data. But there comes a lot of challenges with this architecture. The challenges are that we are now processing the data twice. So we are already processing the data in the streaming fashion, and then we are reprocessing the data in the batch process as well. So that means we are duplicating the processing of our data sets. Now, why are we duplicating the data? Because obviously the streaming data that is coming in, we would want to apply more of machine learning, and we would want to, let's say, there are requirements when we have to update the data sets or merge the data that is coming in. So that becomes a very big challenge on the data lake. So if you have got data that is coming, you have storing the data in the form of files. Now, as soon as you have to start updating the data in those files, which is a very common thing that we do in data warehouses, but in data lake, this becomes a very big challenge. So that is why the Lambda architecture poses certain challenges about data reprocessing. And if you have to perform updates or deletes on the files in data lake, that becomes a challenge. So that is why there are, of course, Lambda architecture is a good architecture, but it does pose some challenges. Now let's see what problems we are going to face with the data lake. Number one is the in fact, the most important problem, in fact, the biggest problem that we have is the data reliability challenge. Now, what can happen? Let's say I'm processing some data and there is some corruption to the data that has happened. Now, obviously, when we are writing the data, we might have overwritten the files, or we might have written the partial data into the data lake. And because of this, the complete data set has become corrupted. So let's say, we have written already 100 files are there, and now we are writing some data and there is a failure in the job. Because of this, we have written out the partial data, and that makes our whole data set corrupt. There is no way that we can roll back. So if we talk about databases or data warehouses, we can roll back the stuff there. But in case of data lake, it is very big challenge to do a rollback. Okay, there is no way that we can roll back the data. On the other side, that whatever data we are writing, there is no validation of the data. So we are continuously writing the data, but we don't know that what was the previous schema and what is the new schema in which we are writing the data. It all depends on the code. So we are completely dependent there that our code is perfect. It is not going to create any problems. So that is why, but when you're writing the data in data lake, there is no validation that is going on. Okay, so there is a data validation issue which is there. Then the third thing is, let's say from one side we are writing the data into files, and on the other side we are reading the data from the files. Now, obviously, when you are writing the data, it might be incomplete data, and on the other side somebody will read the data. This kind of problem does not occur in databases, but it's a very, very common problem when you're working with files in data lake. So that is why the data read may not be completely consistent. So this is one of the challenges that we face with data lake. On the other side, there can be problems, as we discussed, about the updates, deletes, or merge. So we have got the files. We want to update the data in the files. We want to delete some data in the files. Maybe because of GDPR compliance, we want to delete the data, but it's not such an easy job to delete the data from such big set of files. All right. So this is one of the other challenges that we face with data lake. Then there is another issue, like we have in the databases, we have got the option to apply some constraints on the data, like the null data should not go in. We want to apply some check constraints, so that we can do that in the database, but it is not possible to do that on a data lake. So again, another set of problem that we face while working with data lakes. And finally, there can be some query performance issues as well. Now, whenever you keep your data inside databases, we can write some optimize our queries. We can get some really good performance, for our queries. But as soon as the data goes into the files, and you want to let's say we have file sizes of 1 GB, and now we want to go ahead and read some data, let's say one single record. Now, there is no way that we can read one single record. We have to read the whole set of files, and then only we can extract that one single record. So that is why the query performance is very limited, when we are working with the files in data lake. So these are some of the challenges, like reliability challenges, validation issues, updating the data, deleting or merging the data. There is no way that we can apply the constraints, and there are query performance issues as well. Now, these kinds of challenges, we can go ahead and fix it with Delta Lake. So let's see, what exactly do we have in Delta Lake? Now, first of all, let's say, again, back to the Lambda architecture. Now, how can we build up something called as Delta architecture? Now, this is where what we can do, we can get our raw data, which is, which could be our data coming from databases, or, any kind of the historical data that we have. And we have some live data that is coming from IoT devices, or that could be coming from, let's say, the log servers. So we are continuously getting that data. Now, what we can do, we can go and process the data using Spark, the live data which is coming in, and as well as the historical data. And now we can put this data into data lake in the form of Delta. Now, once we put the data into Delta, which means we want to apply the updates, we want to apply the merge, we want to do the deletes, we want to make sure that there is no data consistency issues. So all these things can be solved by Delta Lake. So this is what we have in the Delta architecture. We don't need to reprocess the data twice. We don't need to worry about the updates and deletes. Everything can be taken care by using Delta Lake. So this is what we have in the Delta architecture. Now let's go ahead and see that what exactly is Delta Lake here. Now, Delta Lake is basically an open source component. This was developed by Databricks, and then they made it, made it open source. Now, Delta Lake can bring the reliability, and that's what we have been talking about. It can bring reliability to Data Lake in the form of, the consistency of reading the data and other stuff. Okay, so let's see that how the Delta Lake works. Now, typically, let's assume, or in fact, let's assume we have a Databricks cluster and we have our storage. Now, this is our data lake here. Now, when we are working with, let's say, when we are working with a Databricks cluster, we can install the Delta Lake component. So it's a very small component that is open sourced, and you can install it on your laptops as well. But this is something which is already available on Databricks cluster. So you can install the Delta Lake component on your Spark cluster, and then when you have your data and you want to write the data into Data Lake, typically what happens is it goes ahead and writes the data in Parque file. Now, when you are using Delta Lake, it not just stores the data in Parque format, but it also stores the transaction log. Now, just like we have the transaction log in the databases, in the same way, we have the transaction log inside Delta Lake as well. So we are not just storing the data, but we are also going ahead and storing the transaction log. So whatever transactions are happening, whenever you are updating the data, whenever you are deleting the data, merging the data, or appending the data, for every transaction that is happening, it is creating a transaction log and storing that transaction information inside the storage as well. So that's what we'll see in the demos, that if you are writing the data, how it goes ahead and writes a transaction log. Okay, so that is what the Delta Lake is going to do. It is going to write the transaction log. Now, let's see that how exactly this transaction log is working, and then we'll go and look into the demos. Let's say, we have got our data lake, and we are going to store our data here. So let's say there are two files which have been written out into our folder. So these two files contain the actual data. Now, whenever the two files are written out, correspondingly, there is a folder called _delta_log, and this is where we store the transaction information. So in this particular folder, we are keeping a small file, and this particular file contains the transaction information. So first time when you write the data, so it will contain the information that, yes, we have written two files, and these two files are part of my data. So corresponding to the data set we are writing, we are also going ahead and keeping a small transaction information file. And this file will actually help us give the consistent. In fact, this particular transaction log will actually help us provide the consistency. Okay, let's take an example. So this is, the initial stage where we have written two files, and we have got, the transaction information that these two files are present. Now let's say that on one side, there is a writer process which wants to write the data. And on the other side, there is a reader process which wants to read the data, okay, simultaneously. Let's see how this works. Now, one side, when the writer process is writing the data, it will start writing the data in this new file. So it is just going ahead and in a typical way, like Spark works, it actually is going ahead and writing this particular, writing the data, new data in this particular file. On the other side, let's say the reader process wants to read the data. So what it will do, the reader process will not read the data. Reader process will first go ahead and read the transaction log. So it goes to the transaction log and sees that there is a file called 000.json, and it looks into this particular file and sees that corresponding to this file, there are two files which have been written out. All right, so what it will do, it will start reading the transaction log, which is 000.json. And now from this one, it knows that these are the two files which are committed files. So that is how it looks into the commit information. So this file tells us that these are the committed files, while this file is still in progress. So on the other side, as soon as the writer process has finished writing this data, it will go ahead and now write the data in the transaction log that there is one more file that has been added. Now, but meanwhile, reader process has only read this 000.json. This means it will not read this particular file. It will only read the first two files. So once again, I'll just summarize this part. So first of all, we have got two files and there is one transaction information. Now, while the writer process is writing the data, it is writing the partition file 3, but the reader process, when it is reading the data, it will not read these files. All right, so it will not read these files. It will simply go and read the transaction log. Now, based on the transaction log, it knows that only these two files are available. This is not yet a committed file. So that is the way, the transaction log is helping us to have the consistency of the data between the writer process and the reader process. So writer process, as soon as it is done writing the file, it will commit this information by writing by writing a new file in the delta log folder. And the reader process, while it is reading the data, it will only read part file 1 and 2 because it only read this 000.json file. So this is the way that the Delta Lake works and provides consistency between the reading and the writing of the data. So this is the process of Delta Lake. Now let's go practically see that how exactly does that work. And I'll just take you straight away to the Delta Lake node, to my notebook here. Now, this is my Databricks environment. And in this Databricks environment, first of all, let me show you, I have got a Spark cluster. So I can go to compute and you can see here that I have a demo cluster which is running. And this cluster we are going to use this cluster to work with Delta Lake. All right. Now the second, and of course, the Delta Lake component is by default installed on the Databricks in the Databricks clusters. So we don't need to install this separately. Now, let me just take you to my notebook. All right, so here I'm going to go to my notebook and we'll start working with Delta Lake here. Now, there are a lot of features are available in Delta Lake. We'll talk about them, that it is basically open format. So the data, as I showed you, the data will be stored in the Parque format, but along with that, there will be the transaction log that will be stored here. We'll also go ahead and do a comparison with the Parque format. So you will see that it is much better in performance as compared to typical Parque format. We'll also look, we are also going to maintain the history. So we'll look at the audit history as well. Plus, we'll see that how we can do inserts, updates, deletes, and merge on the files in Data Lake. Then we'll see some of the very good features like time traveling. So these kind of features are available in warehouses like Snowflake. And we'll see it here that, how exactly we work with the time traveling. And we'll see some optimization features as well, along with, all these features. So let's start here. And what I'm going to do, I'm going to go ahead and, create a particular schema. So this is basically a schema for flights data. So I'm going to read certain flights data where I'll have columns like year, month, day, all these different columns are there in my files. And I'm going to read around 500 MB of data, and we'll see that how it works. Okay, so now that we have created the schema, let me just go ahead and read this particular file called flights.csv. Let me just make it slightly bigger. All right, so I'll just go and read this file called flights.csv, and we are going to use the airline schema. All right, so it has just read the file. Let's just see what is there in this particular file or the data frame. Okay, and there we can see this is the data that we have in the file. So we have got the year, month, day, and some information. Then we have got the airline, through which, or basically this is the flights information. So what is the airline? What is the flight number? What is the origin airport, destination airport, scheduled departure, departure time? So all this information regarding the flights, when they are scheduled or if they have completed their journey, then the journey information about those flights. So this is the data set that we have here. Now what I'm going to do, I'm going to take this particular data set or basically the data frame, and I'm going to write it in the Parque format. So what I'll do here, I'm going to take this data frame, which is called airlines TF, and I'm going to write this out in the Parque format to my data lake, and I'm going to partition this by the airline column. All right, so let's, I'm just going to go and run this one. It will take around 30 seconds and it will write the data into this particular location, and we'll see that what kind of data has been written out. And meanwhile, let's move on to the next one while this is getting written. Now, what I'll do, along with writing in the Parque format, I'm going to show, we are going to compare the Parque and Delta format. So I'm going to write the same data frame in the Delta format as well. So only difference that is there is that, again, we have got the data frame. We are going to overwrite any existing data, and we are going to write the format as Delta. So if you look at the previous statement, it says the format as Parque. So we are writing the data in Parque format. And in this case, I'm going to write the data in Delta format. Again, I'm going to partition by airline, and it's going to be a different folder called Delta where I'm going to write the output. So let me go ahead and run this one as well. So only difference, as you have seen, is one is format is Parque, the other one, the format is Delta. Now, while this is getting written, let me show you what is there in the Parque folder. So I'm going to take you to my Azure storage, and let's see if the data has been written out. All right, so here, let's go into the Parque folder. So this is where we have written the Parque data. And now you can see the airlines data has been written. And let's just make it even a bit bigger. So airlines data has been written, and it is partitioned by airline. Let me go to this first airline, which is airline equal to AA. And there you can see that we have written certain files, and this is the out, this is in the Parque format. But there is no other Delta log. We have simply written the data in the Parque format. So this is what we have in the, while we are writing the data in Parque. So these are the files that have been written out for each fold, or for each partition, there will be separate set of files. So all the data for airline AA has gone into this folder. All the data for airline AS has gone into this folder. Now let's look into what is there in the Delta folder. All right, I'm sure it has been written by now. So let's go into the Delta folder. Let's go to airline equal to AA. And once again, you can see that it's the same set of files which have been written out. So there is absolutely no difference in terms of the file that have been written out. It is exactly the same procedure. Again, the Parque files have been written out. Even if you compare the sizes will be exactly the same. So complete set of data has been again written out in the Delta format, or in fact, in the Parque format. Plus, along with that, now you will see something called as a Delta log folder. Now, this is where we can find the transaction information, what has been done. So let's see what is there in the Delta log folder. And there you can see that we have got the first file. So a pretty big number starting with 0, and it says .json. So this is the first transaction we have done on the Delta table. Let me just go ahead and open this file and show you what is present. All right, let me just edit this one, and let's just copy the content from here. And in fact, let's see that what is there in this particular file. Now, what you see here is that now it contains the commit information. So whenever you're writing the data in Delta format, it also contains the commit information. So what time it has been written out, which user has written this data, what is the username or the email ID, what is the operation. So you can see it is the first one is the write operation, and we have used the overwrite mode to write the data. It is partitioned by airline. So all the information of about this about the first transaction is available in this particular file. Along with this one, if you look at, it tells us that how many number of output rows are there. So straight away, if I want to find out the total number of records, I don't even have to go to the individual files. I can straight away find that information right inside the Delta log folder. All right, so here we can find all the total number of files which have been written out. Plus, along with this one, it also contains the statistics information. So for example, it is telling us that these are the files which have been written out. So this is file number 1, and it will tell us that, okay, this file is there in the partition airline equal to A. And it also will tell us that what is the size of the file and some other information. Plus, it is telling us about the statistics. So this means that we are not just keeping the information about the transaction, we are also keeping the statistics information like database keeps. So here we can say in this file, we have got these many number of records, and what are the minimum values for each column and what are the maximum values for each column, that is all, and for each file that is available in the transaction log. So we have, you can see that we have written lots of files here, and all for each and every file, what are the number of records, what are the minimum values for each column, what are the maximum values for each column, that is everything is available here. All right, so this is the first transaction, which is in the form of 000.json that is available here. Now let's go back and see what else we can do. Now let's say that we are going to go ahead and create a table out of it. So which means I'm creating a Hive table inside Spark, and there we'll go ahead. And so I'm creating a database here, create database airlines TB, and whatever data set that we have just seen, we are going to create a table out of it. So first I'm creating a table for Parque data set. So it's going to read the Parque files and create a Hive table that we can query later. All right, so here we have created airlinestb.parquet, and let's see what is the total rows in this particular, inside this particular table. All right, so I'm just going to go and run this command, select count star from airlinestb.parquet, and we'll get to see how many total records are there. So let's just wait for this for a few seconds. And we can see that there are 5.8 million records which are there in the Parque table. Now, also, let me just see the performance of select count star. All right, so I'll just go and run this one, select count star, and let's see how much time does it take to tell me the count of records in this, in the overall files, or in the total number of files. So you can see that it took us 2.83 seconds. Now, on the other side, let me create a table for Delta as well. So I'm using the Delta data set. So you can see it's a Delta folder, the Delta location, and I'm going to go ahead and create a table for this one. So let me go and create a table for this. And once again, I'll go and check the count of records in the Delta table. So we have created the Delta table. Let's see the count of records. And it should show us once again 5.8 million records. All right, so once again, we can see 5.8 million records. Now notice the difference in the performance. So first of all, you can see that this particular command, which was running on the Parque table, it took 2.83 seconds. So what it did, it actually went to each and every file and counted the number of records. So it went to every file and counted the number of records, and then it gave us a sum of that. On the other side, when you look at the Delta table, so instead of 2.83 seconds, it only took 0.59 seconds. So you can see the performance difference, and why we are getting such, why we are getting the count of records such quickly. This is because it is not going to the files and looking for the count of records. It is directly going to the Delta log folder and just getting the count of records from there and showing us the information. So first of all, in these kinds of queries, when we are doing, in fact, it is 0.79 seconds. So in these kinds of queries, it does not have to go to each and every file, read that file and count the number of records. It is simply getting this information from Delta log. So that is the first benefit, or the first performance benefit of using Delta tables. Okay, let's move on. So we have seen the first benefit. Let's look at that. Can we go ahead and append the data into these tables? So what I'm going to do, I'm going to go and read another file called flightsappend.csv. So let me just read this file and see what records are there. So I'm reading a new file, and there you can see this new file contains 3 records. Now, obviously on a daily basis, we go and update the data inside our, we get some new data. So we keep appending this new data into our main tables. So you can see that there are 3 records that I have got. And what I plan to do now, I'm going to take these 3 records and I'm going to append this data into our Parque table as well as into the Delta table. All right, so we have got 3 records. Let's go ahead and append this data first of all into the Parque table. So we are creating the data frame here called airlines append df. And now I'm going to take this airlines append df and I'm going to append it into the same Parque location. So that means in our Parque folder, I'm adding 3 more records. So let's go ahead and append these records. All right, so the previous record count was ending with 079. And now that we have appended the data, 3 more records. So let's see the count of records. And it should become 82. So we have appended, because we have appended 3 more records here. So you can see 3 more records have been added. The count has become 82. On the other side, I'm going to append the same data frame inside the Delta folder as well. So you can see that there is not much syntax difference. It is very similar to how we do with the Parque format. So here we are appending the data into the Parque format. And let me just go and count the number of records which are there. And it should again show me the 82 records. So both ways we have appended the data. Now, one thing which we, because Parque format is not keeping any kind of history. Now let's see that is the Delta table keeping any history? Let's see that in the audit history. So we have got a command called describe history, and we are going to do that on the delta table. Now, this kind of thing is not available in the Parque format. This is only available in the delta format. So what it will do, it will read the transaction log and say, okay, so this is the transaction number 1, or in fact, the transaction number 0, when we had written out some data. So we were using the mode as override. So we have written some data here. Then we went ahead and appended the data. So there was one more version which was created, and you can see that it's a write operation and the mode is append. So this means we are not just we are not just adding the data or managing the data, we are also keeping a track of each and every transaction which is happening on that table. So this is very helpful, because if you want to anytime look into the logs or look into the history of the table, you can find it from here. So this is what the data has. This is how the data has been appended into the delta table. So we can also see that if I scroll down to the right, you'll see that initially when we write the data, we had written 68 files. Now we just appended 3 more records, so it appended 1 more file. So total now we have got 69 files. So how many records were appended? We can even see that from here. So 5.8 million records were appended in the first transaction, and 3 records were appended in the second transaction. So every single information is now available through the delta log folder. Okay, so this is pretty good. So this is, we can do the append in the Parque table, we can do the append in the delta table. So far, so good. Only difference is we have got some good performance, and we have been able to see the log of each and every transaction. But now comes something, which will really give us more benefits in terms of, querying performance. So let's see, I'm going to write one query on the Parque table. All right, so there I'm just, I'm writing some conditions to make it, more complex, saying year equal to 2015, month equal to 1, day equal to 1, and I want to get the data for flight number 98. Now this query I'm running on the Parque table. Let's see what is the performance we get here. Remember, it is actually, because it does not know any kind of statistics, it is going into each and every file which is there. So total there are 71 files which are there. It is going into each and every file and checking that where we have these conditions which are matching. So it has now scanned 71 files to get us these 3 records. So this obviously, it is going to take a lot of time and resources to get us the data. So you can see that it took us 4.61 seconds to get us this particular data set. Now it is also giving us some kind of heads up. All right, let's see what is that. So it is saying that this query contains a highly selective filter. Now to improve the performance of the queries, convert this to delta table. So if you use delta table, that will be much more performant, and it will give us these records in much better time frame. So it has scanned 71 files to give us these 3 records. Now let's see how much time the delta table will take. So I'm going to run this again, select query on the delta table with exactly the same query. Let's run this one and see the time frame it will take. And do you see that? So it took only 1.63 seconds as compared to 4.61 seconds in the Parque table. So we are now getting much better query performance, because what it is going to do, it is going to go to in the delta log folder, it will go and check out the statistics for each and every file. Now, if you remember, if we just go and look into the first file itself, it was showing us what is the minimum value for each column and what is the maximum value for each column. Okay, let's look at this once again. So these are the files, and if we just scroll to the right, we can see the total number of records in the file, and we can see the minimum values for each column, and the maximum values for each column are also available if we scroll down more to the right. This means that before even it gets into the file, it is going to look for, okay, that whether the data that we are looking for is between this minimum and maximum value. Only if if the condition is between this minimum and maximum value, then only it will go inside the file and pick up the data. Otherwise, it will totally skip the file. So this means now, just like in the databases we do partition skipping, here also we are skipping the files. So this is one of the other benefits of using statistics inside delta log folder, that we are skipping the files which are not required. Now consider that we have got let's say 1 terabyte or let's say 10 terabytes of data. And what you want your business users to come in and query the data and see that, okay, they just want to find out very few records out of that 1 or 10 terabytes of data. Now, if you are having the Parque data, it will be, and you will run the query, it will scan actually all the files, or in fact all that 1 terabyte of data, and then only get us these records. On the other side, if we are working with the delta table, it will not go into that 1 terabyte data. It will only go to the delta log folder, look into the statistics. Wherever the statistics are, wherever the statistics say that, yes, you can find this particular record, it will only go into that particular file and pick up the data. So we are going to skip a lot of files because the data is, by just looking at these statistics. So this is, this is actually is going to give us a lot better performance. Now, even with a smaller data set, you can see there is a very big difference in the performance. So as compared to 1.63 seconds, Parque was taking 4.61 seconds. So to think about that, if you have got terabytes of data to process or terabytes of data and you want to query that, the delta can give you some really good performance. So that is one of the performance differences between the Parque as well as the delta. Now, I'm going to show you one thing which you cannot do in Parque. Inside Parque, it is not possible to update the data, or it is not possible to delete the data. Now, if you want to, let's say, if you have got data in a file and you want to update or delete the data, what you need to do, you need to read the whole file in Spark. Then you have to filter those records which you want to remove and then write the data back. So if you are, if there is no way that I can simply go to the file and delete that record. So I'm going to read the whole file, delete the record, and write the data back. But this is something which is, you cannot do in Parque. You cannot go ahead and delete the data. On the other side, now you can go and delete the data and merge the data, even insert the data in the delta format. So you can't do any upserts in the Parque files, but you can do that in the delta table. So let's see how that works. So what I'm going to do, I'm going to read another file called flights_delta.csv. And there are few records which are modified and there are few records which are inserted here. So in total, we have got 4 records here. I actually don't know how many records are new ones and how many records needs to be updated. All right, so I just don't know. So there are 4 records, we need to update them, we need to delete them. Now, typically in databases, if we have to do this activity, it's very simple. So you go ahead and you can run an update statement, or you can run a merge statement, and then you can insert, update, or delete the data. But inside the files, we have to go through all the data to do this activity, not with the delta table. So what we'll do here, I'm going to go and put this data. So these are the 4 records. I'm going to put them into a table called upsert data. All right, so here I'm creating a new table called airlinestb.upsert_data. Now I have got 2 tables. One is this table which contains the updated records or the new records, and then I have got the main delta table. So what I'm going to do, and let me just see what is there in this table. So we should have the 4 records that are new. All right, so these are the 4 new records. Some records are, we might need to, we need to insert it, or some records we might need to delete it from the delta table. So let's go and run the merge statement. So if you have, I'm sure most of you must have worked with SQL. So if you have worked with SQL, you must be familiar with the merge statement. So merge is a very, it's a very good statement that we can run to, simultaneously do the inserts, updates, and deletes. So in the same way, just like you do it in SQL, here also we can run the merge statement on delta tables. So what you see here, so we have got the merge into command. So this is going to be our target table. So merge into airlinesdb.delta. This is our target table. And then we have got using airlinesdb.upsert_data. So this is the target. And the next one, so this is our target here. And the next one is our source. So this is the source. And the first one is the target. So using the source table, we are going to merge the data in the target table. And on what basis we are going to do the merging? So we are going to use these conditions, just like you write a typical SQL statement, merge statement to merge the data. In the same way, we can do it here. So we are going to put up the join conditions based on the year, month, day, flight number, and airline. So these are the conditions we are applying. And now we are going to merge the data from this delta table into the, in fact, from this the new records table into the main table. So once again, if these conditions matches, then we are going to update the records. So here I'm just updating for the demo purpose. I'm just updating one single column. So if these conditions, all these conditions matches, we are going to update the data set. If these condition does not match between the two tables, then I'm going to insert the records. So this is a single statement using which we can we can do update, we can do insert as well, and we can do delete as well. So let's just go ahead and run this particular statement. This will, of course, this will just do, it will do the update, it will do the insert, and it will also tell us that, that how many records have been inserted and how many records have been updated. So you can see here, it is going ahead and it is merging the data between the tables. Obviously, the merge will take a bit more time because it is still working with the files. And you can see here that total number of affected records are 4. That's what we saw in the the latest data. So 3 records have been updated and 1 record has been inserted. So I did not know that how many records were, how many records are new and how many records needs to be updated. But this is telling us that 3 records are updated and 1 record has been inserted. So this is the way, we can merge the data inside the Delta table. So very useful feature if you are working with data lake. So using Delta, you can actually go and update the data into the data lake. Now let's see. So let's see the transaction log once again. So I'm going to describe the history for the Delta table. And let's see what does it shows up. So here, you can see the first one was the overwrite. Then we did some append on the table. And finally, we did the merge operation. So during this merge operation, how many files have been deleted, how many files have been created, all this information will show up in the operation metrics. So here you can see that we have got number of target rows deleted is 0, number of target files added is 4. So basically, whatever operations have gone inside the Delta table is showing up here. So this is how we are not just doing the merge, we are also getting the information what actually happened when we did this merge operation. All right, so let's now that we have seen some benefits of using Delta, in terms of performance, in terms of looking at the transaction log, in terms of performance in terms of doing the merge. Now let's see a very interesting feature which is called time traveling. Now, what is there in the time traveling? Now let's say currently, I'm going to run once again this same, this particular command, and let's see what output we get here. So I'm running the table, I'm going and running the command on the main table, and I can see that for these particular conditions, the cancelled status is 1. So it shows us that, the cancelled status is 1 here. Now, what I'll do, I want to go and, let's assume that, this operation that I performed, where the cancel status was changed from 0 to 1, this was not the right operation that we performed. So which means my data has been corrupted. Now, what I want to do, I want to go ahead and roll back to the previous version of the data. Or maybe, the data was correct, but I just want to see what was there in the previous version of the data. So this is where we have got the feature of time traveling, where you can check any older version of the data. So if you are writing, let's say every day you are updating some data, or let's say every 6 hours you are updating the data. Now what you can do, you can find out that what happened during that, what happened during that particular operation. And if I want to see the older version of the data, I can also see that. So let's see that, by running this particular statement, I could see the cancel status is 1. Let me go and describe, once again, look into the transaction log. So there were 3 operations. And actually, I'll tell you that this particular, this cancel status that you are seeing was updated during the merge operation. Now, what I want to see that what was the data when the version was 0. So I want to see the actual data. So what I can do, I can run the same query, with exactly the same query, but along with that, I'm going to say from airlines tb.delta version as of 0 or version as of 1, which means I want to see that what was the data when the version was 0, or let's say, let's keep it as 1. So what was the actual data when the version was 1? So now it is going to tell me that, what was the actual value of the data when it was during version number 1. And you can see here, during version 1, the value was 0. And with the latest update, with version number 2, it has become 1. So this means I can not just, I can also find out that, by looking at the transaction log, I'll get to see how many transactions are done. And at any point of time, if I want to find out the previous version of the data, I can find it from here. If I want to do rollback, I can also roll it back. So this means if there is a by mistake, there is some wrong process has went on, and we have seen this kind of problems many times, that source system sent out some files, we updated that in our warehouse or in our data lake, and later on we found out that, that operation we performed was on incorrect data, or source sent out the wrong files. So how do we roll back in this case? Now we can look into the time traveling, or we can, look into the version number, what was the previous data, and we can use it to roll back our operation. So very easily, without too much effort, we can easily roll back to the previous version. All right, so this is the feature of time traveling. Now, it's not just about the version number. Sometimes we don't even know, what was the version number, or in fact, we don't know the version number. But what I know is that the data was correct, let's say at this point of time. So during this time, the data was correct. So what I can do, I can not just see, I can not just do the time traveling using version number. I can also do the time traveling using timestamp. So this means that, okay, if I remember the timestamp that, okay, 3 days back, the data was correct. So what I can do, I can go and say from the same table, I can say that show me the data on this particular timestamp. So when I put up the timestamp saying, okay, show me the data for this particular timestamp, whatever was the situation then, I can go and see the data at that point of time. Think about, in data warehouses, we implement things like change data capture. We implement things like slowly changing dimensions. So all these kinds of use cases can now be implemented using Delta Lake. So we are seeing we are able to find out the older versions. We are able to find out that what was the version of the data during a particular timestamp. All this without doing any effort. This is available to us within the Delta Lake. And how this is coming up? This is coming up because we have the Delta log folder. Or in fact, we have got the Delta log based on which we are able to find out this information. Now, let's go ahead and see that what else we can do. So let's say that I want to find out what are the total count of records in my current version. So I'm just doing select count star from Delta folder. And I want to see that what was the initial set of records when the version was 0. So, let's see the difference of records between these two versions. And there you can see that there is a total 4 record difference between the two versions. Now, in the initial version, we inserted some, I think 5.8 million records ending with 079. Then in the next operation, we appended 3 records. So you can see 3 records are here. And in the merge operation, we added 1 more record. So 3 records during the append operation and 1 record was added in the merge operation. And we can see there is a difference of 4 between the current version and the first version. So that is what we can also find out using the time traveling. Now let's move on and see some other interesting features. Now what I can do, let's look at some of the performance improvements. So we have seen some performance improvements already. Now I'm going to show you some very interesting feature. Just like we do clustering of data inside databases, here also we can perform clustering of data. So let's see that I'm going to run a query here. All right, so here I'm putting up a query with a day of week equal to 1, and there is going to group by origin airport, month, and it's going to give us the count of records. Let me just go ahead and run this query. Now, so far, what is the situation? The situation is that the data is spread. I have got around 71 or 72 files. The data is spread across all these across these 72 files. So the day of week, so we only have 7 days, of course, in a week. So some the day of week equal to 1 data is spread across all these 72 files. Now, just like databases, I want to build up a clustered structure. I want to do the clustering of data. That means I want all the day of week 1 data to be together, day of week 2 data to be together, the day number 3 to be together, and so on. So I want the data to be sorted and stored based on day of week. So I want to sort the data and then store it. Now what I can do in this case, so just notice that it took 5 seconds to run this query. Now what I'm going to do, I'm going to optimize this delta table. So I'm going to say, let me optimize the A-lines tb.delta, and I want to sort it, or I want to order it by day of week. So what this is going to do, let me just run this command. It will take around a minute or so. So we should not do it regularly. Maybe we can do this at the end of every week, so we can sort the data if required. Now what this is going to do, this is going to take all the data from, in fact, it is going to take the data from all the files, and it is going to sort it by day of week and then store it back. So this is why, this is the optimized feature available in Delta table. So you can see it's taking a bit of time because now it is reading all the data, sorting it, and then it is going to write back to the data lake. So let's just wait for this to complete. It will take only a few seconds now to complete this one, and then we'll compare the performance. So it's still going ahead, reading all the data, sorting it, and then it is writing back to data lake. Just hold on for a few more seconds. Let's just wait for this one to complete. And of course, when you are doing the sorting or when you are doing the optimizing, this information is also available in the Delta log. So any kind of transaction like, first time writing the data, then doing the append, doing the merge, doing the sorting. So all these operations are captured in the Delta log. Now, what you can see here that it has optimized the data. Now, there are two types of optimizations it has performed. It has first optimization is that it has sorted the data and stored it by day of week. Plus, there were initially we saw that there are lots of files are there. Let me just show that to you. So I can go back to the Delta folder. And let's go back to A line equal to AA. Now, initially there were, this was the file, and these were the other files which were present in the folder. So basically the file sizes were very small. So one file size was 1.85 MB, 4.6 MB, 2 MB, 4 MB. So these were very small file sizes. Now what it has done, when we run the optimized operation, it not just sorted the data, but it also compressed these files. So what it did, it took all the data from all these files and combined them into one single file. So now this is the actual file that we have, and all the other files are actually, it's not required. They are only required for time traveling. They are not required. They are not part of the current, they are not part of the current version. So this is the only file, and now it has combined all this data, compressed it into one single file. So obviously when you are working with Spark, having too many small files can, it can create problems while reading, because obviously there is a lot of overhead involved in reading the files. So because now we have got data into one single file, so maximum file size is going to be 1 GB. So it is going to, if you have got hundreds of files with very small sizes, it is going to optimize that in 1 GB sizes. So that would mean now we have already sorted the data, plus we have also compressed the data into one single file, because we have less than 1 GB, so it has compressed the data into one single file. So these are the two benefits that we get by running the optimize command. One is the sorting of the data, and another is compressing the data into 1 GB optimal sizes. So you can see here that 14 new files were created because these are the compressed files, and total 68 files were removed. That means 68 files have been, they were small files, they have been compressed into bigger files, and total new 14 files have been created. Now some of you might think that where are these 14 files? So obviously we have got, one file in the first partition. If you go to AS, you will find one more file. And in the same way, for each partition, you will find different set of files. So total 14 files have been created and 68 files have been removed. Okay, all right, let's go back here, and I can see there is one question in Q&A. Okay, and I think there is, all right. So let's move on and see that we have got the optimize and Z ordering feature. Now, let's see what is there, once again, what is there in the transaction log. Let's see the information. And we can see the optimized operation is also showing up here. So everything is being tracked here. Now, the thing is, some of you might think that what about these particular files which are no longer in use? So we have seen that all the data has been compressed in this file, and rest of the files like this one and the other files are no longer required. Now, how do I get rid of these files? So this is where I can run another operation, and let me just show that to you. In fact, let's first see that, we have sorted the data. So what is the performance impact? We haven't seen that yet. So we are running the command, and let's see, it took 3.4 seconds to get the output. And in the previous case, when we had run the query, it took us 5 seconds. So basically now from 5 seconds, because we have sorted the data, we have reduced it to around 3 seconds. So again, more performance benefits. Now this is very less because the data size is very small. As soon as you start going into terabytes of data, all these things are going to create a massive impact on the querying performance, and it's going to create performance on, on the writing of the data. So it's going to create a big impact on your data sets. So let's see that whatever files are present, how do we get rid of those files which are no longer required? So what I can do, I can go ahead and vacuum these files, which means I want to remove, it's like a garbage collection. We want to get rid of all these unrequired files. So what I'll do here, I'll just go ahead and, I'm going to go ahead and remove the file. So I'm going to do the vacuum operation. And this means I'm going to remove all the versions which are no longer required. So this is going to remove all the junk files. So you will see that in the folder, and it's going ahead and removing the files. Let's just refresh this one. And there you can see we had got around 7 files. All those files which were no longer required have now been removed. So this is the operation. So there are 2 operations you can perform, let's say, over the weekend. One operation is the optimize operation, that if you want to sort the data, so we can perform this optimization operation over the weekend. And if we want to, let's say, if we want to clean up those dummy files which were not the dummy files, but files which are no longer required, we can perform the vacuum operation over the weekend. So these are some of the features we have seen in Delta Lake. Now, we also talked about that, we can perform, let's say we can add the constraints, and let's see that how we can apply that. So we have, let me just take you to another notebook here. And we'll just go and see, there are 2 more features we are going to see. Number 1, we are going to see that how we can apply the constraints, just like we do that in the databases, how we can apply not null constraint and how we can apply the check constraints. And we will see that how we can, how we can prevent the how we can prevent the, let's say, the incorrect data to be added to the table. Let me show you an example. Let's say I'm going to read a small file here. Let me show you what is there in the file. So we have, this is a new data set that we are going to work with. And we can see, and you can see here, there are 5 records that we have, so there are 5 records. These are the names, and there is a salary column. Now, what I'm going to do, I'm going to go ahead and once again put the data in Parque format. So once we can see the data frame, and we can see mode is override, format is equal to Parque, and we are going to write the data in Parque format. So the same thing we did with the flights data, now we are going ahead and doing with the employees data. All right. And again, I'm just like we have written the data in Parque format, I'm also going to write the data in Delta format. So we are going to see the features of constraints and schema evolution by, once again, by creating a Parque and a Delta table. Okay. And let's go. And now what I'm going to do is, we have got some data in the, we have seen there are 5 records. All right, in the employees data set. Now what I'm going to do, I'm going to create, let's say, 5 more records. So I'm kind of generating a dummy data set, and you can see that there are 5 more records, and this contains ID, name, and new salary columns. On the other side is, if you look at the previous one, it says ID, name, and salary, which means my main data contains 3 columns called ID, name, and salary, while the new data frame that we have got contains ID, name, and new salary. So this is actually not right. The column names should match as well. But here we are generating a new data set that we want to append to the table. Okay, so ideally this should create a this one should create a problem, because the new salary column is not present in the original data. Now what I'm going to do, once again, I'm going to append the data to the Parque table. All right, so let's go and take the new data frame which contains ID, name, and new salary. Let me go and append it to the Parque table. Now let's see, will it work or will it not work? And you can see it did not create any problems. because it did not do any validation checks. So we did not perform any validation check. It simply went ahead and wrote the data. So now if I go and try to read the data from the Parque files, let's see what do I get here. All right, so I'll just go and define the employee schema, and let me just try to read the file. So what we have done, we have written the column called new salary, which was actually not part of the original data set. So ideally, we have got ID, name, and salary columns, but now we have added a new column called new salary, and this was actually not the right column. Now, if I want to append the same data set to the Delta table, let's see if it works or not. So I'm taking the same data set, which contains ID, name, and new salary, and I'm going to append that to the Delta table. So let me just go and run this one. And actually, if you see here, it is giving us an error saying a schema mismatch was detected. So Delta table is not allowing us to write the data where the schema is not matching. So if the column names are not matching, if the data types are not matching, it is not going to allow us to insert the data. So this is one of the other benefits of using Delta, that it does not allow any kind of corrupt data or incorrect data to be added to the tables. In case of Parque, there was no validation, but in case of Delta, it has performed the validation. Now, if you want to, let's say, if this is intentional and you want to add the new salary column, so what you can do, you can go and say, again, you can write the same command. Again, the new data frame, you want to append it to the Delta table, but you have to explicitly say that I want to merge the schema. So now you know that you are explicitly saying that I want to merge the schema. So let me go and run this command. When I'm specifically mentioning that, yes, I'm okay to merge the schema, then only the Delta table will allow to do that. So you see the benefit that if you try to write that unintentionally, if you try to write the data which is not having the same number of columns, it does not have the same column names or does not have the same data types, Delta table will not allow us to write this kind of data. Only when you explicitly mention that, yes, I'm okay to merge the schema between the two data sets, then only it will allow the operation to complete. So this is what is known as schema enforcement. So we enforce the schema on the Delta table that we are not going to allow you to write any incorrect, or the incorrect data set into the table. So this is called schema enforcement. Then when I did the merge operation, we did the schema evolution. So obviously when the new columns are coming into the new data sets, we want to evolve the schema in the Delta table. So running this merge schema command allowed us to perform the schema evolution. So we have seen two features. Let's see that once again. So we have seen schema enforcement. So we are not allowing any kind of unstructured or the incorrect data to go in. And we have seen schema evolution, which is allowing us to improve the schema or add more columns to the Delta table. And one last thing, let's go and look at the constraints feature. So let's see that where do we have got the column. In fact, let's just go down, and what I'm going to do, let's just start from here. And what I'll do, let me just go ahead and create an employees table. Okay, and let's see what do we have in this particular employees table. All right, so we can see there are 4 columns because we have evolved the schema to add this new column as well. So what we see here is now we have got 4 columns. Now, if I want, I can go and start, I can start inserting any kind of data. So let's say I want to run the insert statement. I can say insert into employees table. These are the 4 columns: ID, name, salary, and new salary. And these are the new values that I want to insert. So currently there are 10 records. I'm going to insert this record, and I'm going to insert this particular record. So it should show me 11 records. All right, and there we can see the 11 records are there. Now what I'm going to do, I'm going to apply the constraint on top of it. And what kind of constraint? I can say, just like we do in the databases, I can say alter table employees, add the constraint, or this is the name of the constraint, new salary check. And we are saying that the constraint is either the new salary value should be null or the new salary value should be less than 50,000. So this is the constraint, just like we do in the databases, we are applying it here. The new salary value should either be null or it should be less than equal to 50,000. All right, so yes, it is equal to less than or equal to 50,000. Now that let's just apply this particular constraint on the table. And the constraint is applied. Now it is also validating the existing data as well. If the existing data does not match this constraint, the constraint creation will fail. Now, once we have applied this constraint, now let me insert one more record. And this time I'm going to say that the new salary value is 100,000. So obviously we have applied the constraint. So this record should not be inserted into the table. And you can see here that it is telling us that check constraint has failed. So this is the feature. We can apply the not null constraints. We can apply the check constraints. All these kinds of constraints we can apply on the table. So what we have seen here is that using the Delta Lake, it is allowing us to build a, it's kind of allowing us to build database-like features on top of Data Lake. So Data Lake allows us to store vast amounts of data. We can store, and it's pretty cheap as well. We can store huge volumes of data. The second thing is that it is also giving us database-like features like Schema Evolution, Schema Enforcement, check constraints, not null constraints, and it is allowing us to have better performance. So if we want to query the data or find out individual records from the table, we can do that. We want to apply the merge operations, update, insert, delete, all these kinds of operations we can apply. Now to sum it up, let me just show back to you all the all the problems that we talked about. So first thing, if we look into the Data Lake problems, let's see if it has been solved by Delta Lake or not. The first problem is data reliability. So you can see that now the data validation is performed, so you cannot insert any junk data. Then if you want to roll back, so rollback feature is also available in the form of time traveling. Data reading is also consistent because as the commit, first the data will be written, then the commit operation will be performed. Only when the commit operation has been performed, then only the data will be considered written. So that is why it is going to give us the provide us the reliability on top of Data Lake. The second thing we have seen, we can perform the updates, deletes, and merge on the files. So it's a very useful thing if you have got things like GDPR compliance, or if you want to perform change, you want to get the change feed, or you want to get, let's say you want to build the slowly changing dimensions. All these things you can build on Delta Lake. And we have seen that we can apply the not null and check constraints on the Delta Lake as well. And finally, we have seen the query performance. So if there are small files, it can help us make them bigger files by optimizing. If we want to sort the data in the files, we can also do that. And if you want to find out individual records, it can look into the statistics and give us the the individual records by only going through the files which contains the data. So this is all the benefit of using Delta Lake. And yep, so that's it. This is all I have in this particular session. I hope you enjoyed looking into the different features of Delta Lake, and I would definitely encourage you that you explore this one. This is a pretty good, pretty good component which is available. And in fact, if you look at Databricks, they are focusing very heavily on on the Delta Lake. So that's it. This is all I have in this session. And once again, thank you everyone for joining in, and thank you, Magnus, for having me here. I hope you guys enjoyed the session.